In this video, I am going to show you this very interesting project which is called as LLM Lingua. Before I delve into that, let's discuss retrieval augmented generation. We all know that augmented generation in AI is quite cool. Retrieval augmented generation is an AI framework that retrieves data from external sources of knowledge to improve the quality of responses. This is a natural language processing technique which is very commonly used to make LLMs more accurate and up to date. The whole idea behind RAG is that LLMs are get trained on the data passed in the time. So they are not aware of what is happening currently. In order to make LLMs aware of your own custom data or the latest data, we use various techniques. We can either fine tune those LLMs, which means that we need to alter the weights of those LLMs, which is quite an expensive and time consuming process. The other way is to use RAG, which I just described. But still, there are few issues with RAG, no matter how cool RAG is. For instance, there is a problem which is quite common, which is called as lost in the middle issue, which is a performance drop. So the performance just tapers off with the passage of time, and as your context or document increases, performance really gets a hit. And so you need more resources, which means more cost, both financially in term of latency. And then there is another issue which is quite common, and that is context window limitation. So context window is very important because large language models can only consider a limited amount of text at one time while generating a response or prediction. This is called as a context length. And different models have different context lengths, and when you play around with RAG with these models, you really have to balance it out. But with, as I mentioned, with RAG, this is quite a burning issue. LLM Lingua tries to solve all of these three problems in RAG. So what it does is LLM Lingua uses a well-trained small language model after alignment, for example, such as GPT-2 small or even Llama 7 billion, to detect the unimportant tokens in the prompt and enable inference with the compressed prompt in black box LLMs, achieving up to 20 times compression with minimal performance loss. So this is where um, these researchers, and hats off to them, they have proposed this LLM, long LLM lingua, and also have shown in dollar figures the improvements and also in the terms of latency. And you can read all of this in this very nicely written abstract. Plus, if you want to read the whole paper, you can download it from the right hand side. One of the best thing is that, which I just showed, that they have a GitHub repo where they have code examples, even they have a demo from Microsoft with the Microsoft logo, and there are a lot of other things which are present in this long LLM lingua. Another thing which I found out, that Llama Index also has a collab where Llama Index has gone step by step to show you how this works, and I'll drop the link of all of this in video's description. So if you go here, you can see that they are first installing this LLM Lingua by simply doing pip install and also Llama Index, and then they are using OpenAI in this collab. One thing to note is that you would need a very beefy system for this. You can't run it on even a normal simple GPU. For instance, for this collab, Llama Index used Colab Pro with V100 instance, which is a bit expensive, so beware there. But if you are doing RAG on a commercial basis, then this is nothing. I think this really saves you a lot of costs. And then next, they are loading the documents and then creating the index on it, and then specifying the retriever with the top case similarity too. And then this is our query string, and then they are pushing it through retriever and getting the result on. And this is where they are setting up so a long LLM lingua as post processor. So what they do is they set up this long LLM lingua post processor, which will use the long LLM lingua package to run prompt compression, which reduces our cost. And this is where all of the magic is happening where they have specified this condition compare true question context budget how much your budget is and then reorder context and how many target tokens you want, and this is our ranking method. So amazing stuff. Try it out if you have access to that v100. I don't. I might try it out in on AWS EC2 later to see if it works there, but I need to get a balance of proper instance because I tried it on AWS G4DN instance with 4x large. It didn't work. I think it even need more beefy system. Anyway, so this is pretty much it. If you um, are already using it or have any other thoughts about it, please let me know. Happy to learn more about this. And if you like the content, please consider subscribing to the channel. Thank you very much.